SysML V2 Lesson 2, KerML, the engine under the hood. In Lesson 1, we looked at the syntax, or the code. Now, we must look at the architecture that makes V2 so powerful. One of the biggest limitations of SysML V1 was its foundation, UML. Because V1 was built upon a software modeling language, systems engineers often had to force-fit physical concepts into software boxes. For example, a physical pump or sensor had to be modeled as a UML class, with material, weight, and physical properties added through stereotypes and tags. Energy flow and mechanical interactions were presented using relationships originally designed for software communication. SysML V1 worked in practice, but it forced physical system into software-oriented concepts, making the modeling conceptually awkward. SysML V2 replaces that legacy engine with KerML, or Kernel Modeling Language. It is vital to understand that KerML and SysML V2 are distinct. KerML is the platform-independent meta-language, or the engine. SysML V2 is the systems engineering language built on top of that engine, the KerML foundation, or the meta-model. KerML consists of three logical layers: root, or syntactic foundation. This is the structural foundation. It defines generic elements, relationships, and namespaces. It controls how model elements are organized and connected, but it contains no engineering meaning. For example, this layer knows that one element is connected to another and both have names, but it does not know whether they represent a part, a requirement, or a behavior. Core, or logical foundation, the mathematical heart. This layer adds model-theoretic semantics and formal logic. It provides the rigorous rules for types, features, and classifiers, enabling the model to be mathematically checked for consistency. Because of this layer, the model can logically determine whether a feature belongs to a type, whether inheritance is valid, or whether constraints are violated. Kernel, or modeling capabilities. This layer defines the universe of discourse. It introduces specific kinds of types and features to represent different aspects of reality: data types, classes, and associations. The SysML V2 extension, or the systems library. This sits on top of KerML. This is where SysML V2 lives. It defines the specific libraries we use, such as part, port, action, and requirement, as specialized usages of the KerML kernel. For example, a motor modeled as a part is a specialized KerML occurrence with systems meaning. A signal connection modeled as a connection is a specialized KerML link, and a control algorithm modeled as an action is a specialized KerML occurrence. The systems library simply provides systems engineering vocabulary on top of KerML's generic concepts. 40 Spatiotemporal Semantics. In SysML V1, structure and behavior were treated as two different worlds. In KerML, their definitions are unified as classes, and their instances are unified under the concept of occurrences. An occurrence represents something that exists across space and time. For example, a tire during a 10-minute driving interval is an occurrence. It includes the tire's physical existence in space, its rotation over time, its temperature increase, and its wear during that period. It is not just the tire as a static object, nor just the rotation as an action, but the tire as it exists and behaves across space and time. A structure specializes in objects library. An object is an occurrence that is spatial and persists over time. For example, part-def tire. A behavior specializes in performances library. A performance is an occurrence that is temporal and happens over time. For example, the rotation of the tire, or action-def rotate. A physical part and a behavior process are now fundamentally the same kind of thing, which is occurrences. This allows us to model the life cycle of a part simply as a behavior, finally resolving the disconnects between structure and function. The payoff: automated reasoning. Because KerML is grounded in formal logic, which is the core layer, your model is a database of facts, not just a drawing. This enables inference, asking the model questions it can answer mathematically. Next lesson, we leave the engine room and start driving. We'll look at the usage-focused paradigm, the specific mechanism that kills the block definition diagram versus internal block diagram confusion.